All right, so this video is going to go over homework for chapter 6, which is all about the normal model. Before we begin, I want to make sure that I just review with you guys really quickly that the problem stem is going to tell you that the distribution follows a normal distribution. And that's how you're going to know to do these type of problems. Or it might say something about the distribution is bell-shaped, unimodal, and symmetric. And again, those are both key things that tell you this is the probability rules that we are talking about. Back in chapter 3, I think it was, we did use the empirical rule to find probabilities, and those probabilities still exist. It's just now we need to know, like, what if I'm not exactly 1, 2, or 3 standard deviations above or below the mean? How do I find those probability values? And also, it's not just between values like the empirical rule was between values. This is going to be any kind of probability that we need to be able to find. So specifically in section 6.1, the problem that I wanted to talk about is the last problem assigned in that section, which is 6.18. And it just wants you to find the probabilities given certain z-scores. And so I'm going to do just a couple of these just to show you what we would do here. So if I want to find the probability that z is greater than -0.98. Now, with a normal distribution, it doesn't matter if there's greater than or equal to, because it's a continuous distribution for a random variable. And so that doesn't matter if there's an equal to or a sign or not. Binomial, it matters. Other distribution, it matters. Normal, it doesn't. Because just right above it, okay, is going to be like so close, it doesn't really matter. So it doesn't matter what the mean or standard deviation is, a negative z-score of -0.9 is not quite 1 standard deviation below the mean. So that's this z-score right here. And if I want to know greater than, I want to know this side right here. And I like to draw just a little diagram every single problem because it tells me 2 different things. One, am I above or below the mean? I know that if z is negative, I'm below the mean. If z is positive, I'm above the mean. And it helps me see proportionality wise if my proportion should be greater than or less than 50%. So because I shaded more than half of the distribution here, my probability needs to be greater than 50%. And that's helpful when you go to your normal distribution chart in the back of the book or online or wherever you're looking at a normal distribution chart, because the probability that it gives you, I'll try to put this underneath the document camera here. The probability that it gives you in this normal distribution here is going to be the left side. It is always going to be the left side. So when I go to -0.9 and then over to 8, I get 1635, so 0.1635. But that's always this left side distribution. That's not the side that I want to answer this question. I want the complement. So to find my answer, I'm going to do 1 minus. And so again, drawing a little bit of a picture here is going to be really helpful so that you can see, like, what does my distribution look like? And from there, find the probability that you're looking for. Another tricky one here is like on part B, and I didn't answer this final one for you. You should be able to do that on your own. I want to know what's the probability that z is between 2 values. So again, I'm going to draw this distribution. with this mean 1, 2, 3 standard deviations on each side. And the z-score that I'm looking at below is almost 2.5 below, and then 1.29 above. And so my proportion that I'm looking for is this proportion right here. And that proportion is going to find me the same thing as the probability. Now, in order to find that, anytime you're wanting to find a between probability, you're going to find, excuse me, the probability of the right bound. Okay, and that's going to find you everything from 1.29 all the way down to negative infinity. Okay, so it'd find you that entire thing. But remember, I don't want this piece here, so I'm going to subtract out the probability that z is less than negative 2.47. You'll go find these values in your chart, and then you'll subtract the probabilities to find that middle probability that you want. If you're like, that sign doesn't match right there, you're right. So this is going to find me this tail probability, which is the piece of this probability here that I don't want. So I'm going to find the big probability and take this out. If that's still confusing to you, one thing that I like to make an analogy to is there's like those area questions that you would have had maybe like on your geometry test or on like an EOC or STAR test or something like that. They'd give you these dimensions, and it would be like, here is your patio that you are finding, and it'd give you dimensions, and you'd find like the total area and then take this piece away, okay, to find the area that's left over. Very similar here. You're gonna find the big probability and then subtract out that small tail to find the between probability, to find the probability that you would like to find here. One of the questions here that it asks for in part E and part F, okay, are going to be problems that are not actually on your Z table, okay? They're so small. So E is asking you to find the probability that Z is greater than or equal to 6.07. Well, if we draw just our regular normal distribution, really we only draw out 3 standard deviations. Okay, and remember from the empirical rule that anything past 3 standard deviations, okay, on either side, total is 1 minus 0.997 for both sides. So if I only want this one tail, it'd be that over 2. And that's at 3 standard deviations, because that'd be half. It'd be this just upper half part, right? If I want to go 6 standard deviations, I'm still going, here's 4, here's 5, here's 6 standard deviations, and I'm trying to find that itty bitty tail probability here. That's going to be so close to 0, okay, that we're not really going to include that like value in the table. Once you get past about 3.5 standard deviations away from the mean, the probability is really, really low that something like that's going to happen. All right, the next problem that I want to do in our video here is the first question of 6.2. All right, so, sorry, y'all. All right, so looking at section 6.2, problem number 620 in the book, okay? In this problem, it gives the mean and standard deviation to be a mean of 20 and a standard deviation of 4. Sorry, I'm trying to pull up the exact question here in the book. Okay, yes. Mean of 20 and standard deviation of 4. So a picture of what this distribution would look like is centered at 20 and my standard deviation size is 4. So if I wanted to number this number line, I would subtract 4 to get 1, 2 standard deviations, or I could add 4 and add 4 to again get 1, 2 standard deviations. And so this is what my distribution looks like by just knowing the mean, the standard deviation, and that it follows a normal distribution. On these questions here, you're going to need to find those z-scores and then compute the between probabilities here. So I want to know what's the probability that I am between x equals 20 to x equals 27. So on my distribution here, if I'm starting at x equals 20, starting right here at the mean, and then 27 is going to be right here by 28, and my probability that I'd want to find is this probability here. Now that probability is going to be less than 50% because exactly at 20, if I shaded all the way down, that would be exactly 50%, but I don't want this piece right here. So I need to go ahead and find these as z-scores first. So z at 20 would be 20 minus the mean over the standard deviation, and you end up getting 0, and that makes sense because 20, which is our mean, is 0 standard deviations from itself. If I want to find the z-score for 27, 27 minus 20 over 4 gives me 7 over 4, which gives me 1.75. Now, again, I want to find my right bound probability first. So if you go to your z chart, 1.7 and then to 5 gives me 95, 99. So if I were to find the probability of just less than a z-score of 1.75, that p-value, that probability would be 0.9599. Okay? But that's not what I want. I don't want this whole half over here. So then I'm going to subtract out that 50% that is the other side of that distribution. And that's going to find you the p-value that you would like to find. And so that's just another example of how you do those between probabilities in order to find answers there. Now, one thing that I want to stop and just have you do, if you have a calculator, and you want to learn some of the calculator notation here. I do know the expectation on your exam is to use the charts, the normal model chart, and you'll be provided that, but it is always nice to have a second way just to check your answer. So I'm going to show you guys on both 6.1 and 6.2 how to do that here. Okay, and then you can use this to check your answers on your homework. So you're going to go under distribution like we did for binomial, so second distribution, and you're always going to use the normal CDF because we are always going to have some kind of interval for our normal distribution. So do not use number 1, don't use it, okay? So you're going to go under normal CDF. You're going to do lower bound, upper bound, and then you're going to do mean and standard deviation. So if I was doing a problem like 6.2, I'm going to show you both ways that you could do this, okay? I'm going to use the z-scores first. So if you use the z-scores, you're going to go from 0, lower bound, to upper bound. So 0 to 1.75. And then I'm going to use 0, 1 for my mean and standard deviation because I've already converted to the normal model here by using z-scores. And you can see the probability that we get should match the answer that we got right here. The other way that you could do this is if you actually wanted to just keep the data as it is. Okay, so from 20 to 27 with a mean of 20 and a standard deviation of 4. And it will find you the same thing. Now, again, the difference between these is if you want to use the z-scores, if you're converting to the z-score and you're using the number of standard deviations away from the mean, then you use a mean of 0 and a standard deviation of 1. And you use the z-scores lower bound, upper bound. Here, if you're going to do the data, okay, lower bound, upper bound, mean, standard deviation, but it will find you the exact same thing. For my Inspire users, okay, you go under menu, statistics, there you go, okay, distributions, again, we're going to use that normal CDF function, lower bound, 0, upper bound 1.75, and then it defaults that mean and standard deviation for you. So that's what I always do. You have to use your z-scores anyway. You have to show that work. So this is just kind of a nice check that like I go do this in the table and then I just grab my calculator and do the lower bound and upper bound like this, and then just be like, okay, yes, I did that correctly. Now on something like part A, okay, where you have to find a greater than, so I want from this z-score up, you're gonna just do this. So menu, statistics, distributions, normal CDF. Now in this case, our lower bound is -0.98. And then you can just choose a really big number for your upper bound. So you can, I just do like 1 and a couple zeros. Like it does not matter how many zeros, you basically want it to go to infinity. Okay, and it will find our answer for us. Similarly, if you had to do a less than, then you just leave that lower bound, okay, and then plug in the z-score, and you can see it finds that left side for you, okay? And that same thing here with the 84, okay? That's not just an Inspire thing, okay? So you do lower bound, and then upper bound is a really big number, 0, 1, and close it out, okay? Or if you wanted the left-hand side, really small number, -0.98, 0, 1. And then get to the left-hand side, okay? And again, that should be used to check your work, not to answer the questions, okay? I want to be very, very clear about that. All right, on 6.3, I want us to look at 632 for the video here. So, section 6.3. 632. All right, so in this question, it says that monthly mortgage payments for all homeowners in the city is $2,850. Suppose that the distribution of those monthly mortgages is an approximately normal distribution with mean of $2,850 and standard deviation of 420. Okay. Find the probability that you have any of these values here. So this is our distribution. I know the shape is normal. I know the center. I know the spread. And so in part A, it wants me to find what's the probability that you randomly choose a person and they pay less than, remember less than or equal to, doesn't matter here, $1,200. All right, so the first thing I need to do is convert this to a z-score. So a z-score for 1,200 would be 1,200 minus the mean all over the standard deviation. And when you do that calculation, you get negative 3.93. So if I'm thinking about this distribution that is centered at 2850, 1200 is almost 4 standard deviations away. That is where 1200 would be, almost 4 standard deviations below the mean. That number is not even on the chart, so we're going to say that this probability is approximately 0 if I wanted less than that. Okay, that probability almost does not exist. If I wanted to do part C, what's the probability that somebody chosen at random pays more than $3,600? Again, you're going to find that z-score for 3,600. 3,600 minus 2,550 over 420 gives us a z-score of 1.786, okay? Which I'm going to round up to 1.79 because I just need that for my chart. Now remember, your chart only gives you left-sided probabilities. So when I'm looking at this here, here's 1, 2, here's 1.79. I want this piece of my distribution right there. So when I look up 1.79 on my normal model chart, 1.7 over to 9, the value that it gives me is 0.9633. But remember, that's the left-hand side. That's not the side I want. I want the greater than side. So for my final answer, I need to do 1 minus the value in the chart. All right, looking at section 6.4, let's do question 640. All right, so on question 640, it says that there is a fast auto service that provides oil and lube service for cars. It is known that the mean time taken for oil and lube service at this garage is 15 minutes with a standard deviation of 2.4. And they want to guarantee a maximum wait time for its customers. If a customer's car is not serviced within that period, then they're going to get a 50% discount. The company wants to limit this discount to at most 5% of the customers. What should we guarantee as this maximum wait time? Assume that the times have a normal distribution. Okay, so wait times have a normal distribution, mean of 15, standard deviation of 2.4. Now, we want to take a look at this distribution in this question. Okay, and I want to make sure that my wait times here that I'm guaranteeing people that 5%, no more than 5%, exceed that time. Well, if you remember, 95% of the data is in between 2 standard deviations. Now don't get confused, okay? That means that 0.025, if I divide that in half, is in each tail-ish, okay? So if I want 5% to be over here, I know for sure that I need to divide that a little inside that 2 mark to make sure that this tail is 5%. And again, I'm getting that because it said I want to guarantee. Okay, the company wants to limit this discount to at most 5%. So what is this wait time? What is this X value? I'm going to tell people so that only 5% of the population actually waits longer than that. So if you look in your chart, remember your chart gives your left side. So I really actually want that left distribution, okay, to be 95%. And the way that we're going to do this is an inverse question. So you're going to do this the opposite way. You're trying to find the x value for a given p value. So we need to look in here in our p values, okay, for 0.95. So 0.95 is going to happen between 0.9495 and 0.9505. Okay, and so that's going to give me a z-score of 1.645. Okay, 1.645 is going to give me 95% right here. Okay. I'm then going to let that be equal to my z-score equation. Okay, and then I'm going to solve this for x. So again, just to reiterate, 1.645 is the number of standard deviations from the mean that gets me 95% on that left side, and I want 95% on that left-hand side because I want 5% to be on this top part here. After I know the z-score, I can then set it equal to x minus the mean over the standard deviation, and then I can solve that for x using algebra. So the first thing I'm going to do is multiply both sides by 2.4. And then to solve this for x, I'm going to add 15 to both sides to find the x value. And then a good way to check your answer here is to know, is that value bigger than 15? Because it should be longer than 15. All right, last question here for this video is going to be in section 6.5. Problem 6.46. And in this question, it gives us a binomial situation and wants us to use the normal model to approximate that. So on part A, this is just a good review question. Using the binomial chart here in order to find this, so going to n equals 25, going to the right p-value, and then finding this value in the chart. In part B, you need to find the mean and standard deviation using the equations in this section. So the mean is going to be n times p. The standard deviation is going to be the square root of np and then 1 minus p. And that's going to find you the mean and the standard deviation for your normal model here. Once you find that, okay, you'll find your z values. So you'll find a z for 8. 8 minus the mean all over the standard deviation. You'll find that here. The mean is 10, so 8's going to be like over here somewhere. You'll find your z-score for 13. 13 minus, go ahead and plug in 10. Over what you find for your standard deviation. 13 is going to be over here. And then this is the inside probability that you want to find for that question. So it just becomes a between question like we did earlier in the video. I hope you guys find these homework hints helpful for chapter 6.